Chapter 1.1, we're going to be going over the slope of a straight line. And as we're going to see a little later in this chapter, slopes of lines is very important to understanding the steepness of certain curves. One thing that we won't be seeing though is vertical lines here, because vertical lines are not functions. Their slopes are undefined, so we actually won't see them at all in this section. Okay, so starting off with the slope of a line. Slope measures the steepness of a line, and it's going to be constant, meaning it's going to be the same over any interval for a line. So here's the slope formula between 2 points. So if we have 2 points, x1, y1, x2, y2, then the slope between them is the change in their y-coordinates divided by the change in their x-coordinates. So the slope is m, which is y2 minus y1 over x2 minus x1. So a couple things that we might see later on is the notation here. Using delta, that's delta y over delta x. Delta means change, so it's the change in the y-coordinates divided by the change in the x-coordinates. And we can call this rise over run. Rise because y is vertical, run meaning horizontal for x. So if we took a look at what we see here, if we have, for this graph, if we have 2 points, x1, y1, x2, y2, we want to calculate the slope between them. It's going to be the difference in the y-coordinates, which is y2 minus y1, divided by the difference in the x-coordinates, x2 minus x1. Okay, so let's do a couple examples here. Find the slope of the line passing through each pair of points. First one, we have -3, -1, and then -2, 4. So if we plotted that on the graph to the right, they would be right there where I just plotted them. So what we're doing here is looking for the slope. So we're looking for rise divided by run. So we can probably figure it out just by looking at this one, but let's actually use the formula. So it's going to be y2 minus y1 over x2 minus x1. We can call the first one x1, y1, call the second one x2, y2. It doesn't matter which one's which. We can call the first one x2, y2 and the second one x1, y1. It doesn't matter. But let's go ahead and plug them in. So it's going to be 4 minus -1 over -2 minus -3. And we just have to make sure that we are simplifying correctly. That's going to be 5 over -2 plus 3 is 1. So m here, the slope is 5, which we could check when we went over here on the right on the graph. It went up 5 units, to the right 1, so 5 over 1. Next one, we have 1, 4 and 1, 0. So plotting these, that would be right here and right here. So this is a vertical line if we connected these. So we should have an idea of what the answer is going to be. Let's go ahead and just calculate it. So once again, let's let the first one be x1, y1. Second one can be x2, y2. And let's go ahead and plug them in. I erase that so it's not in the way. So it's going to be 0 minus 4 over 1 minus 1. That's -4 over 0. Whenever we have a 0 in the denominator, that means the slope is undefined. So the slope is undefined because we cannot divide by 0. So vertical lines have undefined slope. Next one, we have 2, 3 and -2, 3. So 2, 3 would be right here. -2, 3 would be right here. Hopefully, once again, we can kind of see what is going on with that, because that's going to be a horizontal line. But let's go ahead and plug it in and see what happens. So it's going to be, let's let the first ordered pair be x1, y1. Second one is x2, y2. So y2 minus y1, 3 minus 3, over -2 minus 2. That gives us 0 over -4. 0 over -4 is 0. So if 0 is in the numerator, the answer is just 0, so don't leave it as 0 over -4, write it as 0. So horizontal lines have a slope of 0. And you can see here what these graphs represent at the bottom. Positive slope is an increasing line, negative slope is a decreasing line, 0 slope is a horizontal line, and a undefined slope is a vertical line. Next thing is the point slope form for the equation of the line. So it's actually the same exact equation as the slope equation, it's just rearranged a little bit. So let's say we have a line with slope m, and it cuts through the point x1, y1. That means for any point xy along the line, y minus y1 equals m times x minus x1. So you can kind of see here how it's the same as the slope formula, except we multiplied this denominator on both sides, so it becomes m times x2 minus x1 equals y2 minus y1. And instead of having points plugged in for x2, y2, we just leave them as variables, so we just leave them as x and y. Okay, so let's go ahead and see an example here. Let's write an equation in point slope form for the line with slope 4 that passes through the point -1, 3, and then solve the equation for y. So we're going to be starting off with point slope form, which is more often than not, that's what we're going to be starting with. So that's the form from right up here. We're starting with this. We are given that the slope is 4 and the point is -1, 3 that it cuts through. Okay, so hopefully you notice too that it's called point slope form for the equation of the line because you need the point and you need the slope. So all we have to do now is actually just plug in. We plug in y1 is 3, m is 4, and x1 is -1. Instead of writing x minus -1, I'm going to skip to writing x plus 1 because the two negatives make a positive. So this right here is point slope form for the equation of the line. And the instructions here also say to solve for y. Solving this for y is going to get it in the next form, which we'll see on the next page. But to solve this for y, we have to distribute the 4 on the right. 4 times x plus 1 is 4x plus 4. And then we have to add 3 to both sides. Add 3, add 3. And we get y equals 4x plus 7. And we'll see in 1 second that this is SlopeIntercept form when we solve it for y. Hey, and if we graph this, let's go ahead and actually graph it. Let's use, instead of using the equations on the left, let's use what we were given right here. The slope is 4 and the point is -1, 3. So -1, 3 is going to be right here. And a slope of 4, that means we go up 1 or up 4 to the right 1. So up 4 to the right 1 would put us off the graph actually at 0, 7. So we connect them as a line, and that would be the graph of our line. Okay, and let's do one more here. We want to write an equation in point slope form for the line passing through 1, -2, and 2, -3. So let's go ahead and write it down. Let's write down our form. Y minus y1 equals m times x minus x1. So we need a point and we need the slope. So we can use either one of these points. We can pick whichever one we want. I'm going to pick 1, -2. You could pick the other one and it would end up working also. And we need the slope. So to find the slope here, we're not given the slope, but we can figure it out by using the slope formula and plugging in our values. Let's let this first one be x1, y1. Second one be x2, y2. We go ahead and plug them in. That's going to be -3 minus -2 over 2 minus 1. That's going to end up being negative 3 plus 2, so negative 1 over 1, so slope of negative 1. Now, once we have that, all we have to do is plug everything in. So it's going to be y minus negative 2 is y plus 2, so I'm just using what's over here. Y plus 2 equals negative 1 times x minus 1. And we can actually leave it like that. I'm just going to clean it up a little bit and write it as negative x minus 1 because the answer here wants it in point slope form. So this is point slope form. Okay, and then if we actually went ahead and graphed this, then we would have the points 1, negative 2. So 1, negative 2, and the other point was negative 3, comma 2. So negative 3, comma 2 is right here. And if we do them in the other color, if we connected these lines, then this would be the line whose equation we just figured out. Okay, and then for the next one is slope-intercept form, which we already mentioned a second ago. So let's say we started with point slope form. So the same thing that we just did. And let's use the fact that every non-vertical line has a y-intercept. A y-intercept is going to be the ordered pair 0, comma some number, 0, comma b. So let's go ahead and plug that in. It's going to be y minus b equals m times x minus 0. If we solve this for y, we end up getting y minus b equals m times x. Add b to both sides, we get y equals mx plus b. Okay, so that's this form right here called slope-intercept form. And that is because m is the slope and b is the y-intercept. So that's 3 important formulas slash equations. We have the slope formula, point slope form for the equation of a line, and slope-intercept form for the equation of a line. Okay, so let's see some examples here where we're identifying the slope and the y-intercept. So the first one is f of x equals negative 2x plus 3. So the slope is right here, and the y-intercept is right here. Slope of negative 2, y-intercept of 3. These are all almost, the first 3 of them are in y equals mx plus b form, slope-intercept form. Next one, we have g of x equals x. So this one we can actually rewrite as 1x plus 0, right? So the slope is 1 and the y-intercept is 0. Oops. And then for the next one, we have h of x is negative 7/9 x minus 5. Here's our m, here's our b. M is negative 7/9, and our y-intercept is negative 5. So just be careful, it is negative 5, not positive 5. And for the last one here, it's a little trickier because this one is not solved for y. So we actually have to solve this for y first. So we have to start by subtracting 2x to the right, and we end up getting 3y equals negative 2x plus 6. Notice that I didn't write it as 6 minus 2x. You could, but it's just good form to have the x first. And now we divide everything by 3. Oops, divide everything by 3. So what that means on the right is we actually have to divide both terms by 3. That's negative 2/3 x plus 6 over 3. 6 over 3 is 2. So once we have that, now we can identify the slope as negative 2/3 and the y-intercept is 2. Okay, so that brings us to the next thing, and that is parallel lines. So two non-intersecting lines are going to be parallel, and what we need to know here is that parallel lines have the same slope. Same slope, different y-intercepts. So let's do an example here. Let's write an equation of the line passing through negative 3, 1, and it's parallel to the line whose equation is y equals 2x plus 1. Okay, so let's go ahead and start with our point slope form for the equation of the line, which once again, that's typically what we start with for these. We are given a point, negative 3, 1. That's our x1 and our y1. We are not given a slope, but we're parallel to this line. That means our line has the same slope as this one. This line has a slope of 2, so our line also has a slope of 2. So let's go ahead and plug this in. Once we have those, we're good. We do exactly what we just did. So it's y minus 1 equals 2 times x minus negative 3, which is x plus 3. Here is point slope form. And we need to solve this for y to get it in slope intercept form also. So y minus 1, distribute the 2, 2x plus 6, add 1 to both sides, plus 1, and we get y equals 2x plus 7. And that's going to be slope intercept form. So 2x plus 7, this one's going to be off the graph a little bit, but that would end up being something like this. And we were told it was parallel to 2x plus 1. So if we actually graphed 2x plus 1, that would be like this. And now we can see that they do look to be parallel to each other. So parallel lines, we denote them with little arrows like that. So they're parallel. Okay, let's do one more example of this one. Let's write an equation of the line passing through 5, 0, and parallel to x minus y plus 2 equals 0. And we want our answer in point slope and slope intercept form. So once again, starting with the usual point slope form, we need our point, which we're given our point at 5, 0, and we need the slope. So this time, once again, we're told that it's parallel. So our line is going to have the same slope as this line right here. This line is not in y equals mx plus b form, so we have to solve it for y first. If we add y to both sides, that's actually going to solve it for y. 0 plus y gives us y. So we get y equals x plus 2. The slope of this line is 1. It's 1x, so that's the slope of our line. So let's go ahead and plug everything in. Once we have that, once again, that's all we need. Plug everything in. Y minus 0 equals 1 times x minus 5. Technically, this is point slope form. Kind of messy, but technically this is point slope form. And to get this into slope intercept form, we solve it for y, which is actually very easy because it's pretty much already solved for y. Get rid of the 0, multiplying by 1 doesn't change anything, so we get y equals x minus 5. And that's slope intercept form. So let's go ahead and just graph that. X minus 5, that's a y-intercept of negative 5, slope of 1, and that's going to look something like this. And the other line was y equals x plus 2. That's going to be y-intercept of 2, slope of 1, connect them, it looks like this. And once again, we can see that these are parallel, so we are good. Okay, and for the next thing, we have perpendicular lines. So two lines that intersect at a 90-degree angle are called perpendicular lines, and the slopes of perpendicular lines are negative reciprocals of each other. That means the product of their slopes is negative 1. If we multiplied them together, we would get negative 1. So what that means, to find a negative reciprocal of a number, we have to negate the number and take the reciprocal. or it doesn't, you can take the reciprocal and then negate it. So you switch the sign, positive to negative or vice versa, and you reciprocate it. Okay, let's see an example. Write an equation of a line passing through -3, -5, and it is perpendicular to x plus 2y minus 8 equals 0. And we want the equation in point-slope form and slope-intercept form. So let's go ahead and start with point-slope form as usual. And we are given our point, -3, -5, and we need our slope. So our slope here is going to be the negative reciprocal of this line's slope. So first we have to solve it for y. So we have to add 8 to the right, subtract x to the right, and we end up getting 2y equals -x plus 8. Divide everything by 2, divide by 2, divide by 2, and we end up getting y equals -x over 2 plus 8 over 2, which is 4. Instead of writing -x over 2, I recommend writing it as -1/2 x. It's going to help us out in a second. And let me just move this down. Okay, so the slope of this line is -1/2. So the negative reciprocal of -1 over 2 is positive 2 over 1, which means our slope is 2. Once we have that, now it's going to be the same as all the other ones. Once again, we go ahead and plug it in. It's going to be y minus -5, y plus 5, equals 2 times x minus -3, which is x plus 3. And this is point-slope form. So there's point-slope form for the equation of the line. Solve this for y by distributing the 2x plus 6, subtract 1 on both sides, or subtract 5 on both sides. We get 6 minus 5, 2x plus 1. And this is our slope-intercept form. Okay, so let's graph that and graph the other line. 2x plus 1, y-intercept of 1, slope of 2, and we connect them. So this is our line that we just created. The other line that we were perpendicular to is -1/2 x plus 4. -1/2 x plus 4 is going to be y-intercept of 4, slope of -1 over 2. And we connect them, and it does look like they intersect at a 90-degree right angle. And let's do one more of these ones. Write an equation of the line passing through -2, 6, and perpendicular to the line whose equation is y equals 2/3 x minus 1. So we have point-slope form. We have our point, which is -2, 6, and we need our slope. So the slope of this line is 2/3. That means the negative reciprocal slope is -3/2. So the negative reciprocal of 2 over 3 is -3 over 2. So let's go ahead and plug it in. Easy enough. We just plug it right in again. That's going to be y minus 6 equals -3 over 2, x minus a -2, so x plus 2. So here is point-slope form. And to get this into slope-intercept form, distribute the -3 over 2. That's -3 over 2 times x minus 3. -3 over 2 times 2 is -3. Just multiplying fractions. Okay, and then all we have to do is add 6 to both sides. So y equals -3/2 x, -3 plus 6, +3. And there is slope SlopeIntercept Form. So let's go ahead and graph that one. We have y-intercept of 3, slope of negative 3 over 2, so down 3 to the right 2, and we connect them, and it looks like this. And the other line that we are perpendicular to is y equals 2/3 x minus 1. That's a y-intercept of negative 1, slope of 2/3 up 2 to the right 3, and we connect those. That one looks like this. And just a little verification, it does look like they intersect at a 90-degree angle, so it looks like we did it correctly. Okay, for the last thing for this section, as we know, the slope, this is going to be slope as a rate of change, but as we know, the rate of change of a linear function, the slope of a linear function over any interval is constant and is just equal to our m, our slope value. However, if the graph of a function is not a straight line, the average rate of change between 2 points is going to be the slope of the line between those points. And this line connecting the points is called a secant line. And we'll see later on, secant line is very, very important. The idea of it is very, very important. And you can see from this graph right here. So we have this blue curve right here. That's our curve f of x. And then we have these 2 points, x1, y1, x2, y2. And we have a line connecting them. The line is a secant line. So the curve, the blue curve, is not linear, but if we connected those 2 points, then it is the average rate of change between those 2 points. So the average rate of change between those 2 points is actually just the slope formula. So we know the slope formula is y2 minus y1 over x2 minus x1. In this case, though, we might not always have y2 and y1. We might have to figure it out using the fact that y2 is the function evaluated at x2, so f of x2, and y1 is the function evaluated at x1. So sometimes we would have to use that fact, but both of these things represent the same exact thing. So let's go ahead and do this last example. Let's find the average rate of change between the points labeled on the graph. So this graph is showing how this person grew over time from when they were born to, it looks like, 20 years old. And then we have the height over here on the y-axis in inches. So it's clearly not a linear path, right? This is not linear, that's not a straight line. But if we want the average rate of change from this point here to this point here, we connect them with this secant line that is labeled, and it's just going to be simply the slope between those 2 points. So we know that slope is y2 minus y1 over x2 minus x1, and let's use this point as x1, y1, and let's use this point as x2, y2. We go ahead and plug it in. That's going to be 76 minus 57 divided by 18 minus 13, and we calculate that, and we get 3.8. So let's actually think about what this means, since it's an actual problem here with actual units. When we're calculating slope, it is y, change in y, divided by change in x. So this is our units for y, this is our units for x. So that 3.8 number is going to mean that the average rate of change is 3.8 inches per year. And that was for between the ages of 13 and 18. Okay, so we can see how that is useful in an actual application using this linear concept of slope, even though the data itself is not linear. Okay, that's it for this chapter.